Alright, hello Algebra 1, it's day 17 and we are still factoring. I think this might be our last day for factoring, but we're doing special cases today in factoring. So I have this quadratic up here. You'll notice it doesn't have any term in the middle. There's no just something x. So I'm going to look at this and if you'll notice that both 16 and 9 are perfect squares. I can take the square root of 16 and I can take the square root of 9. So this is a special case. This is called the difference of squares, and super easy to do. Whenever you set up your parentheses like this, you're just going to take the square root of 16 n squared. So the square root of 16 is 4. The square root of n squared is just n. So that goes in the beginning of both sets. This is going to be a plus and a minus, and then I'm going to take the square root of 9, which is 3. And that right there is your answer. It's as easy as that. But let's double check it just to make sure. I'm going to double distribute this first set of parentheses. I'm going to multiply my 4n through the second set first. So 4n times 4n gives me 16n squared, and 4n times a negative 3 gives me minus 12n. Okay, so I've already distributed this one. I'm going to distribute this 3. 3 times 4n gives me plus 12n, and 3 times a negative 3 gives me minus 9. Now when I look at combining like terms right here in the middle, I have a negative 12n and a positive 12n, and that just gives me a 0. Right, so those just cancel each other out, and I'm left with 16n squared minus 9. So I know I've done it correctly. Okay, let's look at another one. 9x squared minus 1. Okay, now for this one, this is still a difference of squares because I can take the square root of 9 and I can also take the square root of 1. So I'm going to set up my parentheses. I'm going to take the square root of 9, which is just 3, and it's an x. Remember, taking the square root of this is just a single x, so 3x on both sides, plus minus. The square root of 1 is just 1, okay? And I forgot in the last one to simplify this. I'm so sorry. That should have been 4n minus, nope. Next one. Next one. Ha, I'm not there yet. This is your answer. Okay, 3x plus 1 times 3x minus 1. This next one is the one we simplify. Okay, so 16x squared plus 40x plus 25. Okay, so let's look at this one. This one looks more like the ones that you're used to, but there's an easier way to do this one too, because both 16 and 25 are perfect squares. The square root of 16 is 4, and the square root of 25 is 5. So in this one, I can factor this just using that, and I'll show you how it's going to work to give me my 40x in the middle. But if I set up my parentheses, just like this, I'm going to take the square root of 16x squared, which is just 4x in both. And this is a plus and a plus here. I don't have to worry about any negatives or anything like that, so I'm going to go ahead and put those in my parentheses. And then I'm going to take the square root of 25, which is 5. Okay? Now, I'm going to show you how we double distribute, and I'm going to end up, this is our answer, but I want to end up with this if I were to just redistribute this. So I'm going to double distribute this first set of parentheses through the second set. So 4x times 4x gives me 16x squared. 4x times 5 gives me a 20x. Okay? 5 times 4x gives me a 20x, and 5 times 5 gives me 25. Okay, I'm going to combine like terms right here in the middle to get 16x squared plus 40x plus 25. And so that's just a way to check it to make sure that you've factored correctly. And since I already know that I've factored correctly, 4x plus 5 and 4x plus 5, these are the same binomial. So I can simplify this. Instead of writing it long ways like this, since they are both the same and there are two of them, I can simplify my answer to look just like that. All right, I think we might be done with factoring.